am in charge of community management on the Uptime project, and I will be the hosting with Linda Lenkong, with Linda. And I'm very glad to do that. And I hope you'll have a very enjoyable time with us. I will present you the agenda. Before we start, please unmute. In this first part, you will use the chat to ask questions. In the second part, we'll have discussion, and you can have a discussion in small groups. And the first part is recorded. So let me introduce the agenda. After this welcome, there will be an introduction by Yves Guéraron and Karl Rebernik. Then we'll have a presentation of Uptime Platform by Dimitris Napaleras. And then there's a panel discussion with the Uptime end users. It will be moderated by Karl, and the panelists are Jérôme Versik from FFT, Pierluigi Petralli from Whirlpool Corporation, and Vasilis Borsinus from Melis. Then it will be the end of the first part, and the second part will be with using open space technology workshop. It means that we will be discussing in small rooms and in small groups, and you can choose the topic of your discussion. And then we'll have 1 hour and a half, and then we'll have the conclusion. So that's about the agenda. So now we'll go to the next, and I will give the floor to Karl Rebernik and Yves Guéraron for this part. Karl, can you present yourself?
Hi, my name is Karl Rebernik. I'm the coordinator of the Uptime Project. I'm also head of the Department of Intelligent ICT for Cooperative Production at BIBA, the Bremer Institut für Produktion und Logistik in Bremen in Germany. I will be sharing this introduction with Yves Guéraron. So Yves, I'll hand over to you for your introduction and the first slides, I think.
Okay. Yes, thank you, Isabelle. Thank you, Karl. Yes, I am Yves Guéraron, and I'm the innovation facilitator, and I take care of the use of standards on the Uptime platform. And so I will share with you the purpose of this showcase event. It is first to show you through demonstration how the Uptime platform supports a predictive maintenance strategy. To share also with you and with first industrial end users the lessons learned from the use of the platform with 3 industrial use cases, very different ones. I must insist, I think it's important to know that the platform embeds in a unified way components representing years of research and development efforts, mainly thanks to European projects funding. After this event will be also an opportunity to answer your questions related to technical, economical, human aspects when implementing such a new maintenance strategy supported by new technologies. It is also an opportunity to openly discuss in your contacts, concerns, and get your feedback as potential partners, either as users or technological partners, and to bring also your input for a future roadmap of the Uptime platform. So thank you again to Isabelle and Linda for organizing this event. I hope you will enjoy the presentations and the open discussions. We have forecasted to make this event as productive as possible in these remote conditions. You know, initially it was forecasted to make it in the Hanover method. For the reasons you know, it was not possible. So we tried to did our best to reproduce the atmosphere of such an event. So I give back the floor to Karl.
Thank you, Yves. Yes, well, we are an EU project in the Factories of the Future 2017 call. I don't want to really talk very much about the project today because it's more about the solution and our results and how we can provide value for industry, and not so much about our European Union project, but nevertheless, here are the details of the project. 42 months duration, which was due to an extension by 6 months because of the Corona crisis, and we will be closing in the end of February, so this is our last month. We have 11 partners from 5 countries. You can see them there. I won't go into detail who's involved, but we have research organizations like ourselves. We have large industry. We have a number of solution providers and consultancy companies in the team. Our objective was to build a unified predictive maintenance system, and I think that is an objective which we have achieved. Our solution is the Uptime Platform, consisting of 6 components, and we've validated that in 3 different use cases: in the white goods industry with Whirlpool, in the steel industry with Milas, and production systems transport with FFT. Next slide, please. This is the Uptime Platform. Again, not many details right now because we will be going into a lot more detail about that later on, and you will be able to ask questions to all of the component owners and the platform owners. Basically, we have 2 processing layers, one for streaming analytics and one for batch processing. We have Sense, which connects assets, connects sensors to the system. We have Detect and Predict, which does the streaming data analytics, the condition detection and the prediction. We have Analyze, which basically does a similar thing for your batch data. We have Decide, which looks at the proactive decision making and helps you make the best maintenance decisions based on the predicted condition of your assets and systems. We have Visualize for going into explorative visual analytics, enabling you to see what actually matters in your data, and supported by FMaker for risk assessment, which helps you improve your assets performance with data-driven risk analysis, which is a little bit different from static risk analysis, which is normally done. Thank you, and next slide. I think this one will be presented by Yves.
Yes, thank you, Carl. Yes, so why is the Uptime Platform? That's the question. What makes it different? First, I think it is a user-centric approach which puts the users at the center. Everything begins and ends with the users, and it is user-centric from both a business perspective and also a technological perspective. From a business perspective, the users actually contribute to the design of the use of the Uptime Platform to overcome their challenges in their business activities and their ecosystems with the knowledge of their people, of their production systems, maintenance engineers, technicians, production managers, and so on. So from a technical perspective, the platform is open, modular, and evolutionary at low cost. I will not develop, but it follows ISO standards about functional blocks of such an approach, and also use a data model from Mimosa, complying with the standard ISO 13374. And so it is really an alternative approach to a lockdown approach in proprietary and often costly solutions. So it is also a smart data vision, as Carl shown, with combining model-driven and data-driven approaches. Moreover, it uses advanced visualization means, which are easily adaptable for the presentation of data according different users' profile. In a certain sense, it is an example of digital twin. And maybe you are not so familiar with the concept of digital twin, which is already discussed in as the experts community, but from in a nutshell, that means a digital system exchanging data with a real production system. So computing data from various sources and bringing a synthetic information to the user's ecosystem to take together the right decision. And this ecosystem come back to this ecosystem because it includes maintenance engineers, technicians, production manager, but also possibly external stakeholders, and also new skills in modeling, data analysis, to support this the implementation of this kind of approach. So I propose we discuss openly more in detail together with the current end users in a forthcoming dedicated session to develop this what I think it's very important is human, organizational, and also economical aspects for which many of you have expressed an interest in the registration form. So we will talk in more detail about that and about our specificity later on.
Okay, so the impacts and benefits of uptime of the predictive maintenance strategy and platform, I think, are best demonstrated in the use cases. So what we can see here are the three different use cases: Whirlpool for the white goods, MJ Milas for the steel industry, and FFT for the production asset transportation use case. We were looking for initial impacts of increase of overall equipment efficiency of up to 5 to 10%, reduction of the total cost of maintenance between 10 and 20%, mean time between failures increase of 20 to 30%, and mean time to repair increase of 10 to 20%. Now, most of that is still ongoing in evaluation. I think we're doing a good job. Of course, COVID has sort of brought us off track a little bit. The data is obviously different than it would be under normal production and normal production situations. So we have to be careful there. What I'd like to talk about here is some of the benefits and advantages, and also the challenges or efforts that our end users have noticed in the use cases. So Whirlpool really appreciates the standardized approach to predictive maintenance that we have implemented, and also the modularity of the platform, which helps broaden the potential production equipment that can benefit from uptime. So they'll be able to scale it up and across different factories and assets. And another great benefit that Whirlpool has identified is that the solution can also address problems beyond predictive maintenance, talking about production quality, monitoring, augmented reality, and so on. Some of the efforts and challenges that we saw in this use case was seeing that we started in a new production line. The training the algorithms there was difficult because obviously no failures had occurred before. It was new, and so that's a challenge towards streaming analytics. And also we had to integrate very closely with the existing enterprise systems at Whirlpool. In Milas, in the cold rolling steel tape scenario, Milas expect a payback within 2 years of what we've implemented here. So that's great, and they appreciate that uptime facilitates increased productivity and cost effectiveness due to a number of reasons. For example, better transparency of their maintenance processes, traceability of what's going on in the maintenance processes. Obviously, our goal is to lower the maintenance and repair costs and increase the machine availability. Our condition monitoring component allows insight into the roller bearings level of wear. We'll see more about that later, and you can ask questions, and also to predict when the milling rollers should be replaced, which is very important because this is a very recurring activity at Milas, which happens very often. So being able to move from a purely scheduled to a just-in-time replacement of milling rollers is really an asset to Milas. Some of the challenges there was to sensorize the rollers in this very wear-intensive, high vibration, high dirt environment. So that's need to be very rugged. And also training the personnel in that environment was a challenge that we had to address in uptime, and I think we did a good job with. Finally, for FFT, FFT produces or maintains jigs that transport aircraft parts throughout Europe. So these are mobile assets. increasing the efficiency of maintenance operations of these mobile assets is something that they really got a benefit from with Uptime, reducing coordination, management, and reporting overhead, which is very difficult when these things are traveling by air, by road, and by sea throughout Europe. More attractive to the customer, which is a big aircraft producer situated here in Europe, so you can guess which one it is more transparent and on-demand reporting, risk reduction, and reduction of costly breakdowns. So the customer is really benefiting from this approach, and the flexible deployment and good level of integration which we offer for data acquisition, handling, and access and analysis of the data is something that really helps FFT. The challenges, of course, are the mobile assets. So we need to sensorize and get data from jigs which are moving around all the time and are sometimes not even in the vicinity of a network. Digitalizing the data collection, which was previously done on paper by maintenance operators in the field, and the multi-stakeholder processes with FFT, so involvement of the customer, with logistics operators and others. So as you can see, very diverse use cases and very diverse feedback from the end users as to benefits and advantages of our modular system. So next slide. So the Uptime Offer is what we're here to talk about today. So what can we offer potential customers and potential technology providers? We have narrowed it down to three basic packages that we're looking at. As I introduced at the beginning, we have the streaming analytics layer and the batch analytics layer. So we can provide either of those as for your needs as a basic package. The streaming analytics offer obviously includes the platform itself, the detect and the predict, so the streaming analytics and the visualize part. And the purpose is to provide technical health evaluation and a strong prediction engine based on stream data processing. The batch analytics offers the components that you need for batch data analysis. And the purpose is similar, with a small difference that the prediction engine is for historical and existing data by batch. And finally, the fully adaptable offer is sort of the larger customizable package, which can combine all of the stuff that are in the other and the other two offers according to your needs. So you can even combine batch and streaming data analytics, which can be very helpful in some cases. Okay, the next slide. I think we are finished with the introduction, so I will hand back to Isabel, I think, for instructions on the next part.
Yes, thank you very much, Carl. Thank you very much, Yves, for this presentation. And I'm going to give the floor to Dimitris, who will present the platform.